Okay, so this is my third run through on this. I'm kind of struggling. We need to make sure that we really practice because the first time I went through, I had slides missing. The second time, it only recorded audio, even though I had the video on. I have no idea why it did that. I hope that doesn't happen Sunday, and I guess we'll need to ask Benzie on why that could have happened because I had the video on. It just didn't download with the video. I don't know. Irritating. But anyways, so this is just another practice run through, and if you have any questions, text me. And like I said, you won't hear the kids in the background on Sunday. They're playing. We've got them on the monitor here. Okay, so I'm going to get started. And I'm going to have index cards, and that may be a good idea for y'all too because I end up flipping through my notes the whole time. It's kind of unprofessional. And I noticed last time I was like leaning over. I tend to spin around on my office chair, and I talk too fast. So that's why we got to practice a lot because we notice these things. The more you watch yourself do it, the more you realize what you're screwing up on. And unless y'all are just really good at this, because this is all new to me. So let me pull up my presentation. Okay, so as I said before, Alexis and Andrew are going first, and I'm going to say thank you for y'all's insight on your mathematical patterns and everything else. My name is Micah Maddie, and today I will be covering Pascal's triangle. So what is Pascal's triangle? Pascal's triangle, as our book states, is one of the most interesting and useful patterns in all of mathematics. It's a numerical array that's used to solve easy or similar problems, like the ones in our math homework that we did on Pearson. On my math, this would help a lot with those word problems. So it was named after this man, Blaise Pascal, but it was used in China as early as 1303, which was way before he was born. So I don't know why it was named after him. So this is just an example that I found on mathisfun.com, which is probably Benzie's favorite website because she thinks math is fun. I do not. So all these triangles that are going to be on these slides are the same triangle, same numbers. They had it laid out really easily on Math is Fun. It's a little more simple than what is in our book because I started with going through what's in our book and it would have been about a 20-minute long presentation. So I dumbed it down a little bit for us. You're welcome. This is just the basic version of Pascal triangle, like I said. And we'll first identify that this one does have a diagonal pattern. The first column or the first diagonal row is all ones. The second diagonal row is the counting numbers, 1, 2, 3, 4, so on. And then the third row is triangular numbers, which I didn't know how to find those until I found this cool little diagram. And it shows you pretty simply on how to use dots to find your triangular numbers. So it goes from 1, 3, 6, 10, and so on. And there may be an easier way once you get into the larger triangular numbers instead of having like a million dots all over your page. So the fourth row is tetrahedrons, and then it ends. And this is, like I said, the same triangle. This one is a symmetrical pattern. Sorry, hold on. Hush, Anthony, play with your toys, okay? Okay, so where was I? Like I said, on Sunday, my husband will be home and he will be playing with them. I've got them on their monitor. So this one's symmetrical. The numbers on the left side are an exact mirror of the right side, which it makes it easier that they drew that line down the middle because I couldn't see the symmetry until that was drawn, and it makes it pretty clear. So this is the same triangle. This one is, the pattern is, it is by the powers of 2, which it starts at 1, and obviously 1 to the power of 2 is 1, but the second row, 1 plus 1 is 2. Then you just do 2 squared is 4, 4 squared is 8, and so on and so forth. And since I'm running out of time, I'm going to show you these other patterns that it found, but there's a bunch of different ones that go into depth, and I'm just going to show you the pictures of it and let you know. This one is the pattern of exponents of 11. So that was pretty cool. I would have never found that pattern. And then this one shows the squares that you can find within the triangle. So as you can see that this Pascal's triangle makes word problems so much easier because it helps you identify the patterns involved with the numbers in that problem. So I hope you learned a lot, and Alexis and Andrew, if you'll have questions, just text me. Hopefully this one will save correctly because the last one, it didn't save the video, it just did audio. So I don't know if I exited wrong or what. So I'm going to try to upload this one and send it to you, and y'all try to practice yours so we can just slap them all together on Sunday and be done with it. All right.